We essentially let all of you drive the panel. So you ask your questions and we will get them answered. My name is Marianne Biangardi, and I'm in charge of business development at Schmershel, Treloar and Company. We're a full-service CPA firm. Today's topic is how to save time and improve profitability with 3D printing. Oh, okay, hang on one second. Sorry, I hit a pop-up there. Our panelists will be discussing how you can save time, increase profit, our product offerings, and improve profits with 3D printing. So start thinking of your questions and we'll get started with some introductions. Today we have 4 amazing panelists. They're all engineers, manufacturing experts. They know 3D printing backward, like the back of their hand. Welcome everyone. First, we're going to start out with Mark Bowers. He's the founder of St. Louis Makes. Andre Casteau, he's the founder and lead engineer at SLU Center for Additive Manufacturing. Brandon Wegge, an expert in additive manufacturing. Mike Hill, founder and president of Hill Innovative Solutions. And I'm actually going to change things up and let each of these panelists give you a short bio about themselves, as their background is just so technical. So Mark Bowers, let's start with you. And go ahead and unmute and let us know a little bit about yourself.
So just as a point of refinement there, I'm actually not technical and not an engineer, but I want to set everybody's fears aside. I'm on a panel with engineers, which in my mind has elevated me to a comparable status. So I'm practically an engineer. You can see Mike laughing at me already, and I've got a good laugh out of Brandon and from Andre as well. So I was a business manager in an earlier life in charge of new product development at the Toro Company up in Minneapolis, Minnesota. And so I'm very, very familiar with the financial implications of timelines, especially on new product development projects. And with 3D printed technology, really aware of what that can do to shortening those timelines and cutting costs and taking that out of the system. So my background in history is corporate new product development, some entrepreneurship, and now as executive director of St. Louis Makes, a regional economic development nonprofit that is focused on lower middle market manufacturing, which in layman's terms just means small privately held companies that are less than 100 million in net revenue. That's me.
Great, thank you. Andre, would you like to go next?
Yeah, thank you. So my name is Andre Casteau. I'm the lead engineer for the Center of Additive Manufacturing at St. Louis University. My background, I'm a chemist by training, but I've been using 3D printing to make custom research aids for the last 6 years. And now my new role as lead engineer is to help the community and the students at large bring these techniques into their workflow.
Great, thanks, Andre. Brandon?
So I come from the aerospace manufacturing process. I kind of discovered what we call additive manufacturing. It's interchangeable with 3D printing, but I mean, this is a manufacturing process. This is a robust process. So I always call it additive manufacturing, or AM. I discovered this as we were looking for creating spare parts for older airplanes. And we would typically see a multi-year lead time on these old parts that had last been produced in the 70s, 60s. And that's how we got to additive manufacturing as a technology. And I've had the opportunity to kind of see it over the last 8 years, being deployed across the industry, watching the industry really stand up. One thing is additive manufacturing last year was, I believe, a $9 billion industry across the United States, and it's growing at about a 20% rate. So this is a technology that's developing. I'm also very honored to be part of the advisory board for the St. Louis University Center for Additive Manufacturing, where Andre is working. I think that is a great opportunity for us to help businesses in St. Louis learn about this technology. So looking forward to this. Thank you.
Thanks, Brandon. Mike, you're next.
Mike Hill, and I've been in product development and engineering for almost 20 years now, starting off in sporting goods. And so I've developed products and used additive manufacturing and 3D printing in aerospace, safety equipment for mining, industrial equipment, power electronics, consumer products. Across multiple different markets, and am now, as Marianne said, operating my own product development company where I help manufacturers develop what's next, what's their next product line look like. So, thank you.
Thanks, Mike. So we are going to start actually with Mark Bowers. I'm just going to, while we're waiting on your chat questions, let's just go ahead and get a lead off question for Mark. Mark, you were so excited and you were one of the main drivers for organizing this panel on 3D printing. Why is this topic so important and exciting for manufacturing?
Excuse me. So the personal reason why it's exciting for manufacturing, to me, why it's exciting for manufacturing is that I straddle that gap between old school and new school. And so I remember really well old school teams where you would have engineers in far-flung locations, oftentimes in other countries, and you would need to send things out that had to be physically manipulated. And sometimes you had to wait for those physical iterations to come back from overseas. Or at the very least from other facilities in the US, and just the time and the impact that that had on timing was huge. I mean, you don't have to have very many iterations before a relatively simple and straightforward product literally can take 3 years to get to launch. You know, and I'm not even talking anything that has the air tolerance complexity of aerospace or biomedical. I mean, you know, just straight up construction equipment or agricultural equipment. I mean, not that there's some precision there, but there's nowhere near the level of precision that you have in aerospace. In those industries, you were seeing literally several years to launch. You know, not to mention the reality that I think Brandon had mentioned earlier about legacy parts. And we would have entire meetings and teams dedicated to trying to figure out what the strategy needed to be down to the sub-SKU level on legacy parts and the components that they were made of. Because if you think about that across a company's portfolio, and the companies that existed for decades, you're talking about being able to supply parts that could potentially cover thousands of models, like tens of thousands of models. And so if you were to make an investment to keep those parts in stock, that has huge financial implications for the company. You know, and in addition, one of those financial implications is just leasing all the space and creating the system to track all of that. So, you know, to bring this full circle, the reason that I'm excited about it is because it has real world immediate implications for saving time, and that translates into real world immediate implications for saving money. And it doesn't matter what level of complexity you have. You can realize that even in, you know, I'm not going to take a shot at the aerospace guys, but a lot of times the aerospace guys will say, oh, you know, if it's not aerospace, then the air tolerances are, you know, and there's always some kind of derogatory word that's fitting there. And the reality is that aerospace operates at much tighter air tolerances, but bad work doesn't have to do with how tight your tolerances are. Bad work has to do with whether or not you hit the tolerances specified. So on 3D printing at any level of tolerance, you can now do work that you previously would have had to have sent out or waited a long time on. So the implications, there's not really an industry that doesn't benefit, I guess is the point that I'm trying to make. You know, it's not just aerospace and biomedical and things that are highly refined. You know, it's construction equipment, farm implements, it's agricultural, it's everything. And so to be able to take a couple of years out of the system and look to the advantages that you get in 3D printing as the primary driver to that saves a ton of money. And your speed to market obviously is really, really strong by comparison.
I think you're absolutely right, Mark, and I think it's even evolved past that, right? I mean, I remember 20 years ago when we first started using 3D printing in the safety equipment. The reason that we used it is because it would take 12 to 14 weeks to get a prototype injection mold made that you didn't even know whether we'd have a mold. Spend money, the upfront capital, which was $20,000 to $30,000 on an injection mold, just had a part come off that didn't work, and then you had to start all over, and you lose that lead time, you lose that capital, you lose that ability. And with 3D printing, when it first coming on board at the time, you know, Andre, you probably don't remember this, but the paper mache type 3D printing, right, that fell apart in your hands, but it looked pretty. You know, but it saved a lot of time, and it saved a lot of capital, and it answered a lot of questions at that time. But it's evolved so much past that to the point that you can, if you do have a design issue or design error, you can iterate past that, right? And everyone, in product development, product management is talking agile and iterative design practices now that used to be constrained to software development because there's no capital involved with it. Well, guess what? Now you can use, you can manage projects a whole different way because of additive manufacturing. It allows for that iterative design approach and process. But even beyond that, the technology is advancing such that it does hold tolerances for biomedical and for aerospace. That is just, I mean, it is the speed that the technology is advancing and allowing for literally change in every industry, not just not just injection molded parts now, but now aerospace parts, now biomedical parts, now project management is changing because of it. I think it's all because of the advancement in the technology and the investment that's taking place inside of the additive manufacturing industry.
And I'll pile on that. I think Mike had a great example there of the injection molding, where there's a lot of upfront non-recurring costs required to do the tooling. And the great thing about additive is that you can, it's basically the shortest distance from the engineer's mind to an actual product, and you don't have any of those intermediate steps. Now, the kind of the trade-off there is that you don't get an economy of scale necessarily with additive manufacturing. The 100th one you print costs the same as the first one you print. And so knowing those kind of limitations and where it makes sense is in some respects the biggest challenge of additive, because it can be a game changer in a lot of different ways, but it is not the solution to every problem. And finding those requires some knowledge of the technology, a technology that is changing very, very quickly, to know what the state of the art is and what the art of the possible is. And the other thing I've found is there's a secondary kind of ancillary benefit to additive, and that is a lot of companies have younger engineers that have probably grown up doing 3D printing. They were members of first robotics teams, and they've been printing things almost their entire life. And to give them that avenue inside of a company, I have seen it over and over, can really unleash some innovation and allow them to get product in hand much faster than they traditionally would when they do have to go through the learning of what an injection mold is necessary and all these other steps. It can really kind of unleash your workforce in some respects, which is a nice bonus.
Great, thanks. I'm going to go ahead and read one of our chat questions. We've got one here. What companies are currently using 3D printing for production or prototyping? Do you have any examples? Brandon, would you like to?
Yeah. I mean, like I said, this is a $9 billion industry right now. So, it would probably be easier to name the companies that aren't using this in some way, shape, or form. This is really used across the board. It is a viable manufacturing process. Again, the challenge is that there are lots of different ways of printing. There's lots of different materials. There's lots of different machines coming online. It is changing every day because it is rapidly growing. You're starting to see it really all over the place. UPS stores were going to have printers in them, and the vision there was that instead of shipping a part to you, you could just have it printed at the UPS store and go pick it up. I think they've come off that a little bit, but lots of people are seeing this as an opportunity to really transform their products or their supply chains.
Wow, that's really cool. I really love it. So our next question here, I feel like I'm getting background noise. I'm not sure. Does anybody else hear that? Okay. Next question here is, how much does a 3D printed part cost? Just average, I guess. Anyone have a rough idea?
I'm going to throw out the school answer to that and say it depends. Because it really does. It's just like whether it's machine part and the complexities of a machine part, or if it's an injection molded type part, right? What the mass is, and the materials. So there's a lot of different variations, and I'm gonna, now that I just chimed in, I'm gonna punt this to Andre, and let him kind of set him up and say, hey, what are some of the different variables that drive cost?
Yeah, it really does depend. It depends on what you need out of the part. If you're looking for a final product, that's going to cost a little bit more than looking at just a prototype. If you just need something in your hands that you can physically manipulate and see if your vision is actually coming to life, obviously that's going to be way cheaper. You can, sacrifice on material properties. If you need the final product, you obviously need something that's going to be robust and high strength. And it really depends on what technique. There are printers out there now that can print in composite materials or metal, and those are much more expensive to run than something printing out of plastic or paper if you're still going that route.
Thank you, Andre. Let's see here. Next question. It's kind of on that same line. Is everything 3D printable cheaper than traditional prototyping?
I'll start by saying, so the answer to that question is no. I'll follow that with what Mike said. It depends. I mean, look, it wouldn't matter if we were talking about old school manufacturing, it's still going to depend on the materials and the amount of time, the level of complexity. There are all kinds of variables and factors. What you need to look at is you need to look beyond the cost of the material, and you need to look at the time saved in other processes and the amount of time that you save streamlining that process and what that means in terms of time to market. Like if the part costs more than it would have cost traditionally, but I get an extra year of revenue off of the new product, that's not really a comparison. At that point, you're willing to spend to get that part done because, it has huge implications longer term for the business. So there are a number of variables that you need to take into consideration. I want to mention as well, I'm going to throw this in a couple of times, but we'll start here. I want to mention that Andre's with the Center for Advanced Manufacturing at SLU, where I'm also on the advisory board with Mike and with Brandon. And if I were the owner of a manufacturing company, that's where I would start when I had these questions and I was outside of a webinar, is I would bookmark that, I would find it, I would save Andre's contact information, or just contact me or Mike or Brandon, and we'll get you in touch. Because you think about it, right? The university's objective is to educate students. So you're probably going to get a higher level of education and a higher focus on what you're working on and a more straightforward answer, because the only agenda is to educate students. So now all of a sudden you've got access to PhDs that otherwise would have cost you, or PhD candidates that otherwise would have cost you a ton of money. So, when it comes to answering these questions in the course of your day-to-day business as a manufacturing company owner or even a product manager, you need to know what the resources are in your community that can give you the most straightforward answers. And the only thing I'm saying is that when that question comes up, because it'll come up on every single part, that's where I would start to get my answers to that question. And the other thing that you got to think about then as well is that, given SLU's history in this community, chances are pretty good through their network that Andre's going to be able to find you somebody in the private sector that could help you as well. So, know who your university resources are, know where their strengths are, and be able to lean into them, because that goes a long way towards helping you plan early in the process what those costs are, how to manage those costs, what the time savings is, and what what those offsets are. So I'm done with my my answer and with my advertisement.
I'd like to follow up on that advertisement actually, and I would suggest, if I was owning a company, that I would go one step further back, and I would go talk to my engineers or the people that are on the shop floor, because additive can be for the prototyping, but it can also be things that can help streamline your production system. Tooling is a great application for additive. One-off specific kind of geometries. There's all kinds of ways. So I would go talk to my engineers or my production teams and say, where are the headaches? Where do you think additive manufacturing could be used to help you? And then I would go to the Center for Additive Manufacturing. The nice thing about SLUCAM is that it's not a supplier that you would have to write a statement of work for, and there's they're trying to make profit. They're just trying to help advance this technology, and it just seems like a great resource for smaller companies to dip their toes and start to see some opportunities and see some examples of what additive could do for them.
just again, I think the back to the question also of what manufacturers are using this and using additive manufacturing, and Brandon hit on it a little bit, but I think that where the additive manufacturing has been extremely successful, especially in manufacturing, is when companies have been able to get creative with it, right? And they're not using it just for a prototype; they're using it for a fixture, right? And if you have a machine shop and you're making your own fixtures and not 3D printing your fixtures, then I'm going to make the blanket statement and say that you're throwing away money, because it is cheaper and faster and more accessible, especially through resources like SlewCam, to do fixtures cheaper. There's companies now that are doing their first parts off of 3D printed molds, as opposed to machined aluminum or P20 steel molds, right? And they're saving a lot of money off their first runs and first batches because they're able to do that. So I would say that, being to Brandon's point, taking the technology and the resources to the engineers, to the plant floor, and saying, hey, where can you creatively think through the use of this technology, is where you're going to find a value add that you didn't think of, because most people are thinking of it in a linear fashion right now, that I've got a design and I go print it, right? And they're not thinking about all the other processes that it takes to make that part, and where additive manufacturing can really affect that part, affect your manufacturing process, and drive costs down, or more importantly, speed to market down.
Yeah, and just to kind of round off those thoughts, we are a resource for the community, but like Mark said, our goal is to train engineers. So by coupling with community, local manufacturers in the community, we are making better engineers. We're teaching these kids how to think additively instead of just traditional manufacturing.
That's really cool, guys. I really, so just from a outside perspective, I'm thinking if I was a manufacturer, which I'm not, I'm far from it. If I had a assembly line or something and I needed a part, instead of waiting 6 to 9 months for one to be produced somewhere, I could just have you guys 3D print it and it would work. Or is that not the case? Or it might just hold for a little bit. It's, temporary fix, or you're just trying to I'm just trying to grasp my head around this because I'm kind of like from an outside perspective.
So I'll take this one. I'm gonna use Mike's answer of it. It depends, And so if there are cases where you're trying to get first article out, and so you might have a manufacturing process, say casting, which is extremely efficient and has high return on investment after higher quantities, but it takes a long time to get off the ground. So it might be a case where additively manufacturing aluminum parts until you can get that casting line up and running would be a great way of producing those parts and getting that production line started faster. It depends very much, but it also could be where additive could be supporting that. Like Mike mentioned, printing the molds instead of going and machining those out is a great way of getting parts faster, right? And it might not be cost effective, but if speed and throughput, if you're in a theory of constraints kind of environment in your production line, that's all that matters is speed and throughput. So it might be a solution there. I would also say, and Mark kind of mentioned on this opens up some potential other business models for companies. And this is my kind of personal example. I have 2 3rd graders, so obviously we can't have anything nice around here. And they broke like a handle on the shower, and I had to buy a little injection molded little sprocket thing, for $3 online, which meant that somebody, Delta Faucets, was holding that in a warehouse somewhere and had to ship it here. That was something that if I could have downloaded a digital file of that, I would have gladly paid them that money, and I could have printed it in my house and had it up and running the same day. So it really kind of gives you some ways of thinking about products a little differently.
That's awesome. So really anybody could potentially use this, even for parts around your house. Like if you did have a 3D printer or access to one. It depends. Again, yes, we know. Right. But does the part hold up equally as well as a manufactured I mean, and how fast is it? Like you're saying that same day, it can print it that day? I'm just curious.
In that one example, yeah. I mean, so that's a simple little plastic part. I would say, for larger things, again, quite large parts that are made out of metal can take a lot longer, as well as having a lot of post-processing steps that are necessary, surface roughness, machinings, heat treatments, all of those things. So it's not a simple answer, and I think that goes to the nature of the complexity of additive manufacturing. There are so many different modalities, different materials, how you print. It's not like like we have LaserJet and we have inkjet. Those are the kind of 2D printers that we have. It's all over the place and it's changing. And again, I think that's where something like SaluteCam can be beneficial. You can throw them a model or a suggestion and an idea, and they can turn that around and say, here's how long it's going to take, and here's how much it's going to cost. And
That
here
is
you are.
very cool. Very cool. I mean, Andre, you might have a little intern. I might just sign up over there. I think I'm just fascinated by this. Okay, we have another chat question. How much does material affect print time? That's an interesting question. Who wants to take that? Andre?
Yeah, I can take that. So it affects it greatly. Obviously, your softer materials are going to be easier to work with, just like in traditional manufacturing. The harder the material, the more time, more post-processing that you're going to have with it. So if you're looking for something like Brandon said out of metal, it's going to take a long time, and it's going to have post-processing steps that are required, because you're going to have to sand it, grind it, smooth it in some way, and obviously it's not so easy to do that with metal. Whereas with soft thermoplastics, you've got a wide range of treatment options that are very delicate, and can do that post-processing very, very quickly. Just as an idea, something around the size of, and I work in a lot of biomedical applications, so something around the size of a human head, we can print and have ready to go in a couple of days.
That's pretty cool. So what materials are, I'm sorry, the follow-up question. What materials are available for the rapid prototyping?
At SaluteCam, we mostly focus on plastic materials. So we have some just prototyping plastics like your ABS and your ASA, the basics. But then we can go up to some high strength materials such as your carbon fiber infused nylon. There's some aerospace grade materials known as Altum, or your PEC and your PEEK materials. That's kind of our focus right now.
Cool, thank you. So can anybody come down there and talk to you? Like if I really wanted a part, I mean, not obviously I wouldn't. It would cost like 20 times more money than me just ordering on Amazon and waiting probably for like a little shower part. But anybody can come down there and ask you, right?
Yeah, anybody is welcome to come use the center or to reach out to us. We've got a website. We're on LinkedIn if you're on that network. But yeah, we encourage the community to reach out. And that way we have things to talk about with our students, right? We can say, this is what's actually going on in the community and across the globe, and how you're going to be working with this in the future.
Cool, thank you. And we have another question. How reliable are the 3D printed parts? Mike, do you want to take that?
Yeah, I think, and this was something that I wanted to chime in on the previous two questions too. Is the typical "it depends" answer. No, it really is. You've got to compare apples to apples, right? So if you're making a part out of nylon or polycarbonate injection molded, and you 3D print a polycarbonate part, you're going to have similar performance and characteristics, right? But if you injection mold a polycarbonate part and then you 3D print a PLA part, right, you're going to have completely different performance characteristics. So I think you need to have that in your mind, that whatever it is that you're that your end goal, your end design, right? Just as if you are engineering something. If you specify a material, then you need to make sure that you 3D print with that material or better. And I think that's another area that SLUCAM can help with, right? Especially with the students, because if you're used to working in polycarbonate, right? And you go down there and find out that you could do a carbon fiber print or an Ultim print and get 2 to 3 times the performance or life out of the product because you at a comparable price point, it's worth doing that. But a lot of times, especially being on the engineering side, your focus and you're copying material characteristics from a previous design. You're not necessarily looking at that, and I think that's where having that resource and those students that are researching it regularly, that are plugged into that network, right? Hey, there's additional metal fabricate or metal printing technologies that are coming on board, right? And we talked a little bit about that with the Xerox, the new Xerox machine before the call. There's a lot of new stuff coming out there that just again, when you're in the day-to-day trenches of work, you don't necessarily keep your pulse on, right? So kind of recap everything that I just spit out, right? Just if you want the same performance out of a 3D printed part, you need to make sure that you're specifying the same materials and characteristics when you're going into it, and then don't be constrained by what you've previously used as a material, because there are newer materials coming out every day in the additive manufacturing environment.
Yeah, and to add to that a little bit, I think we can look at a couple of the big companies that are using this in their daily applications. I mean, there were 3D printed parts on the Mars rover that just landed a couple days ago, and it wasn't widely advertised, but they're using them. I think there was 5 different components on that mission that's over on Mars now, and there are regulations for these parts, just like any other manufacturing process, and a lot of 3D printed parts are meeting or exceeding a lot of those regulations now.
Yeah, and Andre, thanks for bringing up the perseverance, because I've been meaning to mention that as well. I mean, that is a great example of why additive manufacturing works. So there's one perseverance rover, right? So there is no economy of scale that would justify injection molding, a lot of tooling. On the flip side, weight is everything for that application. And when you're printing end item parts, additive manufacturing does give you an opportunity to make parts with geometries that cannot be machined in typical ways. You can really optimize the part for weight. And so, that is, in some respects, a great application where additive makes sense. You can spend a lot more time engineering. You can print one part. You can make sure it works. You don't need thousands of those parts. So you don't need that investment going forward. And all these questions are good about kind of like price comparisons. Again, additive manufacturing is an entire industry. There are so many materials, so many different processes. You can go down the Target and you can buy a 3D printer for $100, and it has about an 8-inch bed basically of what you can build. I've seen printers that are 55 feet long, and they use to print boats and large layup jigs for composites. So the reason you're getting all these kind of it depends answers is because it's much broader than just 3D printing. And I think that's, again, goes to the complexity. This is an entire industry that is standing up quickly. And that's why, having something like a SLUCAM to help understand what's going on is so important.
I'm going to jump on and add to that as well, and just say that even if you were talking strictly about old school manufacturing, I can't think of a single question asked where the answer wouldn't be, it depends. So, it's more that this is, that's just the way that it's going to go in industry in general when you're talking about engineered products. And I think that when you're in a business-to-business selling environment, or whether you're the sales engineer or whether you're the business manager, I mean, those are the answers that you expect. And it's with customers, oftentimes an iterative process of refining what the question is. And it's not like the question itself is wrong. People just understand there's a starting point, and you have to work to that level of refinement so that you both understand what's best for the needs of the customer company that you're serving. But the answer, initially at least, is still always going to be it depends. You know, because there's complexity and there are a lot of details that need to be sorted through, and there are generally a lot of options. You hope many of them are not good so that you can see the good ones really quickly, but that doesn't mean that you don't have to go through the exercise of qualifying them. So it's gonna depend for a while, no matter how you're manufacturing it, no matter what you're doing. And I don't think that's necessarily different than if you were working in other materials as well. You know, I mean, I think about that, and I think about, you know, what would be analogous in say the foods industry. You know, I mean, if somebody said, hey, we're going to come out with a new potato chip, you know, how do you make that? Well, you know, the answer obviously is going to be, it depends, because there are a lot of different ways to make potato chips. As straightforward and as low complexity as they might appear to an aerospace engineer, you still have options that you have to eliminate, and you have to align with the needs of the marketplace. So when we say it depends and we laugh about the answer, we could be laughing about that answer just as easily if we were talking about old school 1970s era engineering, because, you know, you'd still need to, it would still be an iterative process during which there was a lot of information that needed to be gathered and refined, both internally on the engineering side as well as in the marketplace around what the end state of that, or the end environment that product or piece was going to be used in. So just kind of defending some of the answers that when we joke about them, because, you know, we're used to making those jokes at work, but, you know, for anybody that's maybe not in that space, you know, these are jokes because these answers are fairly commonplace. So just saying.
Well, I think you hit on something big there, Mark, and started Brandon with the reality that 3D printing can be, it's different. You can make lighter parts with 3D printed. You can do geometries that you can't do in traditional manufacturing, and I think it's important to recognize that and to on the design side try different things, right? And you know, I made you know, the joke earlier, right? You get to teach your engineers that they can now have undercuts on parts. You know, but that's true with 3D printing. You can, and additive manufacturing, you can. This is it's a completely different design approach, and the sooner that you can get your engineering and your manufacturing team off that learning curve, understanding those points, and trying new techniques, the faster you're going to be able to adopt something that is going to be industry or business changing for you.
Yeah, and we've all emphasized the complexity of 3D printing, and I think something that we've kind of glossed over is how quickly that complexity has grown. So the whole 3D printing field is only 30, 40 years old. And then in the last 10, 20, 15 years, it's really seen some exponential growth. So SleuCam is also just a resource to come bounce ideas off of. If you're not even sure where to get started in the space, feel free to shoot us an email or come down to the space and we can chat about that, about what the options are that are out there.
That learning curve, I think, just as a last build on that, Andre, as well, that learning curve for companies is going to be insanely important. I mean, if you look at this and you think, you know, like some people now in hindsight thought that the internet would just be a fad, then you've lost a significant amount of competitive advantage. I mean, if you're really driving the business for growth, then you need to understand the technologies that are in all likelihood going to become a really integral part of what you're doing. And to skip this or to wait and follow, you know, in the number 3, number 4, 5, 6, 7 position in your market is essentially to permanently damage and hinder your business. So, you know, those conversations are valuable for reasons beyond the here and now. They have value in the future that is not going to be realized unless people act on them.
Yeah, I'm going to throw one more on what Mark there said. You know, another way to really damage your business is to go invest a lot of money in 3D printing before you really understand the application space and how it makes sense for your company. It is changing so rapidly that you know, a printer you buy now could be obsolete and replaced by a much better technology 1 or 2 years down the road. And again, I think that's where SleuCam is a great opportunity to kind of learn where the technology is. And I think once you understand a business case or an application inside of your company, maybe it does make sense then to lock in and put some capital investment into it. But before that, you know, I think you really got to make sure you're very, very deliberate in understanding the business model and the payoffs and the long-term ramifications of this before you start investing.
I have a note here in chat from Don. He says, and by the way, Mike taught me, a sales guy, how to write a program to produce a 3D printed part. So if I can do it, anyone can. Thanks, Mike. So that's pretty cool. So I guess anybody really can, if even salespeople can be taught. So let's see, there's another question here in chat. Can SlewCam help optimize designs for 3D printing? Andre?
Sorry, I was taking a note. Yes, we can. So that is one of our goals, is that we wanted to invest not only in the technology, but in personnel to help utilize the technology. So if you don't know how to design for 3D printing, and it is a little different than traditional manufacturing, or you don't know how a 3D part should behave after it comes off, we can discuss that. And we have student resources, faculty resources that can help address those concerns.
Is there a certain program that you use for that? I'm just personally curious.
No, pretty much any design software, we can make it compatible with 3D printed parts.
Okay, cool. Let's see here. I have another question that just popped up. Why should I use Slew over an online 3D printing service?
That one.
Okay, go ahead, Brandon.
Independent non-advocate of SlewCam, even though I totally am an advocate. I mean, the difference I see is, as somebody who has used a lot of suppliers and gone out for bid, is that again, where SlewCam is that they are not there necessarily to make money. They are there to teach their engineers. They are there to help St. Louis, really the region, understand this technology and adapt it. So their motivations are different, in my opinion, than an online form at some supplier. And you never know, there might be some geographic arbitrage going on where they're printing that. They could be printing it in, a foreign country or something. They get the cost down because cost is important. And so I just don't think you're going to have that control loop of, is this a good design? I think an online form, a lot of these companies, they're just going to print whatever you send them, kind of without a human really taking a look at it, and they're going to send it back to you, and they're going to charge you, and they're going to make their profit. I think the difference with SlewCam, it is an opportunity to say, even if you don't have a model, if you don't have the design software or the expertise, you can go there with a napkin sketch, and I think Andre would help you get to a solution. And the focus is not on just making some money. It's really to help the region learn how to do this. Now, ultimately, as you're building that capability, I do think those online things, companies can be very useful. If you are prototyping and you have high capability, that might be a better solution than investing in a lot of in-house printers to a certain point. So I'm not saying they're bad. I just think as you're learning about this technology, that's what SlewCam really offers.
Yeah, I mean, I would definitely, knowing all of you guys, it's better I would go work with Andre for sure versus go online. I mean, he's great. He's local, community, yeah. So thank you for answering that, Brandon. How does anybody have an idea of how much how much would a 3D printer actually cost? I mean, if I wanted one in my house, which I probably can't afford, but I mean, Andre, how many do you have down there, like actual 3D printers?
So we have 4 commercial grade 3D printers. So what that means is that the manufacturer has set some limit on a success rate. So if we print something on our printer, we have a 95% success rate. So 95% of the time, that part's going to come off exactly how you designed it. If you just want to get into the space and just start playing with a 3D printer, they're as cheap as a couple $100. But then that's something that you're going to be building, and it's going to have its own success rate.
Well, I'd have to I'd probably get that just so I could play around with it at home before I actually had enough knowledge to be your intern. No, but how much does a commercial one cost?
They're anywhere from tens of thousands to hundreds of thousands of dollars. And
Wow.
for a really nice metal system, they're in the millions of dollars.
Wow. Yeah, that's pretty cool. Okay, let me see here if we have any more questions in the chat. How is the workflow different from a 3D printed prototype versus traditional manufacturing? We might have touched on this a little bit, but what do you think?
You know, it depends. You know, previous traditional engineer does a 3D model or a 2D model in some type of CAD software program, and then that model is created into a two-dimensional flat drawing with dimensions, and then that's routed to the different processes, right? Whether it's a machining process, whether it's a stamping process, or bending process, or molding process. And then from there, there's usually some level of post-processing, secondary process, or treatment, coating, that type of operation. And then obviously the logistics amongst all of that. And then, you know, that in addition to that, you have the whole supply chain to make sure that there's parts, you know, there's metal on hand to do that fabrication, or there's plastic on hand to do that molding. So that's kind of the traditional manufacturing model versus 3D printing. You know, depending, you know, you've got the material that you've got to have on site, but it's really, you take that 3D model, you no longer have to create that two-dimensional or that dimensioning detailed drawing. You just take that model and you import it directly into the 3D printer through a slicing software, and you click print, right? So there's a lot less kind of logistics and operation stuff. Usually there is some secondary post-processing off of the 3D printer, but again, it's you know, my experience is it's a lot less than perhaps. So if you make something out of aluminum, you know, it's a lot less than having to get it anodized or some other type of chemical treatment that needs to be done. So.
One thing also is it can kind of change your philosophy on it a little bit. So the nice thing about being able to additively manufacture something quickly is it allows you to fail fast. So instead of spending a lot of time making sure you have the manufacturing process, all the stamping, everything absolutely right, because you're going to waste a lot of money if those parts don't fit together. You know, I've encouraged my teams to, you know, fail fast, just try and print it, because it really doesn't take any time. And if they don't fit together, then we'll just reiterate on it faster. So instead of having a meeting with 10 people to make sure it's absolutely perfect, you know, we can fail 4 times for the cost of that. And so, you know, it really speeds up your iteration factor. And it could be that it is part of that, where you start with an additively manufactured prototype, you know, try a couple iterations very, very quickly, very cheaply and quickly. You know, get to something, and then you have a higher confidence so that you can go into a higher fidelity prototype with traditional manufacturing processes faster. So again, it's just a different way of thinking about things, really.
Thank you, Brandon. I think, okay, I don't see any more questions coming up. I was going to ask everybody to give some final thoughts before I wrap up. Just like closing thoughts for everybody, for the, you know, like most important things you think about 3D printing, or anything you want to leave the audience with. Mark Bowers, do you want to start?
Yeah, I'll start. So a couple of things are, I would go back to the discussion that we had about getting ahead of the curve. You need to get ahead of the curve, and you need to understand what your options are now and what your options likely will be going forward. I would also get a relationship going with SLU, Center for Advanced Manufacturing, SLUCAM, because that is your in-market resource that is definitely academic positioned. It's a resource that, you know, SLU doesn't brag enough, I don't think, about what they have available on campus in the community, and it's a resource that is going to give you access to something that you're not even going to appreciate the reality that you otherwise wouldn't have been able to get. I mean, like, your normal is already a way high as a bar. So I would definitely engage with Andre and Andre's team. That's going to be a really cost-effective solution for understanding things. And then I would look at what the projects you had that maybe were the most immediate in need were, start slow so you didn't burn yourself out in terms of budget and in terms of overstepping where you were in the learning process internally. And at that point, I'd say you're off to the races. The last thing that I'll close with is, I'm with St. Louis Makes, and if there is anything we can do to help the lower middle market manufacturing community, so once again, we define that as less than 100 million in net rev, privately controlled, based in the central Midwest. Please look us up online and join our email list so that you get invitations to our events. Many, if not most, of the events that we're doing these days are dark. So they're industry only. We don't publicize them. They're not on the website. They're, they're invitation only, and they're discreet, not mass market invitations. So if we can help, that's what we exist to do. And if you need contact with Andre or anybody else in the marketplace, St. Louis Makes can help you with that as well.
Thank you, Mark. Andre, any closing thoughts or takeaways for the audience?
Yeah, I would just like to summarize that it's a growing market and growing application with additive. And SLU's goal is to train engineers, but also to stay relevant in what we should be training them. So we've invested in this market, so potentially the smaller and mid-sized manufacturers don't have to burden that investment. You can use us as a resource until you can justify the cost. But we don't get we get something out of it, and we get the ability to train better engineers.
Very cool. Thank you, Andre. Brandon?
I'll go back to what I started with, and Mark laid out a very compelling case there of this technology is coming and it's here, evolving quickly, and it will allow a lot of companies to really differentiate themselves. Doesn't mean it's the solution to every problem, but there are a lot of opportunities to use this. And again, the first step I would take, go talk to my engineers, go talk to my production floor, understand where their day-to-day problems are, and get their suggestions for input of where they think additive manufacturing can be used, because you might be quite shocked by how many ideas they have right off the top of their head.
Thank you, Brandon. Mike, you're next.
For me, it's additive manufacturing. It's been longer than most are aware, and it's actually, it continues to grow, and it continues to grow exponentially. But as been mentioned a few times, it's a lot cheaper to fail with additive manufacturing, and I think that allowing, and it does make better engineers, and it does make better innovations, because you can. It is so cost effective to fail, and so for me, it's get creative, be fun, play around with it, introduce it to employees and engineers alike, and let them just get crazy with it, because if you're really looking to grow your organization, and be innovative and cutting edge, with additive manufacturing, there's really no reason not to, because it is so cost effective to do so, especially with organizations like SLUCAM, that for me, it puts the fun back into engineering, right? You're not just shuffling papers, you're actually getting to do new creative things, and the companies have repeatedly, companies that have been successful with additive manufacturing have been successful because they've been creative with the implementation of the technology. So that would be mine, is have fun with it, because it is a fun technology.
Oh, sorry, I was on mute. It does seem like a really fun technology. I think I'm going to look at one of those machines. Actually, I think my neighbor might have one, so maybe I can try hers out first and start making some stuff and see how this goes. So I thank you guys for all this great info. I mean, this was a great panel. It looks like we're pretty close to time, and since I don't see any more questions, we're going to go ahead. Jake, if you want to put the slide up. Thank you. So we hope that everyone has found value in the panel today. We look forward to your feedback. Please reach out, connect with everyone on LinkedIn. All their emails are up here. So Mark Bowers, Andre Casteau, Brandon Wegge, Mike Hill, they're all, take a screenshot. We will follow up. I think you're going to get an email from the Earning Curve with all this info in it as well. And connect on LinkedIn so they can answer any question you have. Thank you to all the sponsors. Feel free to reach out to anyone. Enterprise Bank and Trust, Commercial Trelure and Company, Spoke Marketing, St. Louis Makes, Carmody McDonald. And in 2 weeks, no, I'm sorry, 1 week. What am I saying? We have all these back to back. Next week, March 2nd, is our legal panel, Legal Considerations for Managing Distribution and Supply Chain and Go-to-Market Strategies. So it's been an honor to be your moderator today. Have a great day, and we will see you all next time.
Thank you, everyone.
Thank you.